Right, good afternoon, just. Right, I'm Martin Milner, and I'm going to be talking to you about what it says up there. Now, Milner Associates are part of the RSK Group, which is a large global environmental, soil and water consultancy, and I'm limited. Now, I mean that in the most modern sense. Sometimes they call it competence, but I like to go back to the old meaning of limited. I have limited knowledge about timber and construction, and that's what we focus on, and that's what we do within the RSK Group. And we also bring in, we've got a materials and science structures group, which has got some timber technology support for that. But where we sit is on the engineering side, looking at designs and remediation of timber buildings. Sadly, looking at remediation of timber buildings. Now, timber construction is about knowing your structure. Now, unfortunately, I come across many situations where the term mass brings up different meanings. I don't know what's the matter with our industry. Most of you are in our industry. We can't help ourselves, can we? 1 minute it's timber, next it's lumber, bit of wood, or maybe board. We just mix and match. How do our customers or the insurance industry have a chance of understanding our terminology? I don't know why you call it mass timber, beyond me. So I looked it up in the dictionary. I thought, okay, that's architecture. I'll go with that. And that's a noun. That's what mass means as a noun. As an adjective, involving or affecting a number of things. And that's what I get in meetings, if we're talking about timber frame construction as opposed to CLT or glulam structures. They say there's a mass of timber in there. And what does that mean? So I finally find something that resembles what I think our industry is trying to say. And it's a verb. Assemble into a single body. All that wood, lumber, timber, all coming together as one component. So I will take that as mass timber. But we do confuse our industry. Mass defects, or defects in mass timber. We'll look at some of the root causes in my "Are you serious?" moment. But condensation is something that we don't think about. And it can be a problem. Condensation doesn't happen all the time, and you will get dry timber during the periods where condensation is not occurring. But rain happens in this country, and there are famous sayings, happens and rain happens. And we've heard about the moisture highways of going down the grain of timber. And with the different orientations of grade, you will get that different moisture highway in the product. So rather than, Paul's going to this afternoon talk about good practice detailing and avoiding the problems, I've got the awkward task of showing how to repair some of these problems. It's almost like I'm shutting the gate after the horse is bolted. But things do happen. So therefore, some of this, briefly in this 20 minutes, we can go through what it is. Now, I'm looking at it from a structural point of view. I'm not looking at it from a point of view of the source of that moisture. We will look at some of the things to talk about later. But where is this source? That needs to be removed first of all before you can do any repair, obviously. But one of the things that upsets me is that if the architecture was wrong in the first place, or the building physics was wrong in the first place, you can't just repair it and put back what you've got, what you had before. If you had a leak before, what is the opportunity of that leak again? Are you putting something back which is going to return in a couple of years' time to repair it again? Is that a sustainable repair? I don't think so. And it's the limitations of that repair too. What are those limitations? What are you actually doing in the repair? And what is being addressed? We try to undertake it in 5 steps. The first thing, you arrive on site, or you're given the project to look at, or the case. The first thing you've got to consider is the safety, obviously. The safety of these buildings. Wouldn't be an interesting point to ask all those that have done inspections on CLT buildings, how many have gone to do that inspection, all the structural engineers here, to do that inspection on the basis that there was some structural movement or signs of it other than a spongy floor? Were there any actual signs of distress? Because I find that quite rare. And this might answer some of the questions about the school owners or the local authorities. They see no actual defect. It's not like a spalling concrete or something. And it's worth reminding ourselves that it's not just in timber world that we have issues. We have issues in steel world and concrete world. It's just that we're more focused on the timber. Ensuring safety is the most important thing, obviously. Are the occupants going to be okay? And we'll look a bit later on about the residual strength of CLT and why perhaps we're not seeing these defects occur as something to be concerned about structurally initially. And yes, there will be some safety precautions, some acroprops or some higher level support systems. What is the first thing you have to do when you're looking at safety is make a judgment call as to what is required. Do you need to evacuate the building? Do you need to prop the building? Are people allowed in? Remove the cause of the defect. Obviously that's got to happen, hasn't it? Obviously got to happen. So you need to know what the defect is first of all. There's no point doing a repair if it's going to repeat itself, etc., etc. Remove that cause, whatever that may be. If it's during construction, the cause, check that it was during construction and it's not a condensation or a leak that's been fixed. So a bit of history review is needed to check through the process. The next step is the assessment. What are you going to do for the repairs? Which brings you into step 4, the what if. What if you did this? What if you did that? What if you did that? And so on. And we'll look at those in a moment. And then the action to do the repair. And the appropriate follow-on trades to finish it off. If I jump straight to the assessment side of it, is, first of all, what is the material that you're repairing? Now we've heard earlier that mass timber isn't just cross-laminated timber. And as my wife says, no wonder it's cross with all those repairs you're doing. What is the material? Are we looking at a board Are we looking at a laminated veneer lumber? Are we looking at glue lam? Each one needs a different approach. Is the sponginess of the roof or the floor because it's a chipboard, well not chipboard, an OSB decking on the top over it? Is that the cause of it? Or in the bathroom? What is the damage, the loss of section? So full investigations by the various folks in the room here to identify where is the scope of this damage. It's no point repairing something if it's still got damage in it. Or is there? Is the fact that some of the structure stronger than it needs to be? It was said earlier that maybe the cross-laminated timber or glue lam solution is not the right solution for the project. May have been timber frame or a closed panel, as I think you said. Could be the option. So I always say to myself, hold on a minute, I've got joists at 600 centres and everyone's happy. Then I've got solid timber all the way across, i.e. joists at 0 centres. Is there a residual strength? Is there something we don't need? I mean, interestingly, to the floor of the engineers here, how many engineers actually design three-dimensionally in CLT, or is it single spans? Yeah, quite rarely on the 3-dimension. It's stronger than it needs to be quite often, and particularly in wall structures. It may be that it's needed for buckling or whatever, and maybe the defect is away from the sensitive area, which might answer why some of these structures stand up when they shouldn't. How many times have people seen a report that say 100% decayed, but it's still standing there? So what strength is there? And are you putting in support structures unnecessarily? These are the things you need to consider. What is the loss of section and what is the damage? Then you've got to ask yourself, what is the structural requirement? Was it originally designed as a terrace, but now it's just a flat roof? Was it originally designed to have parties or play football on, but now isn't, because they realised the vibration of people running up and down was not a good look? Or was it originally designed to be a green roof with soil and goodness knows what on top, and plants, in which case they decided actually the maintenance of that and the cost of that was too much. The client now wants just to have it as a flat roof. So you've got opportunity to say, well, what is the structural requirement? Do we need it? And I've got 2 drawings down there. First of all, what is it? And then as soon as you identify a problem, in this instance, we've got water coming in below ground level. You can't see it. It's been identified. And immediately, you put your hard hat on. You've got to think also about the access. How do you get your props in? How do you get your repairs in? What is the safety? The safety of the materials you're bringing in, the size of the materials, the skills available. What type of contractor is going to be doing this? Because we all know contractors' life. We have the head contractor, then they subcontract to the other folks. And the other folks can be any sort of person available. So what are the skill base of those? That's the key. What is the skill base of the actual people doing the work? Because it's got to be tailor-made to them, otherwise it's going to be a continual mess. The logistics. Yes, you could replace a whole wall of CLT, but how do you get it in there? How do you move it around? Etc., etc. It's a whole list of things you have to think about in the assessment process. As I said before, the remediation options dependent on the wood product. If you've got thin planks, the chances are you're going to replace them totally. OSB board, you're going to want to replace that totally. Once you start to laminate, could be laminated OSB, could be laminated boards, could be in any format, then you've got a chance, as we've heard earlier, about only some of the laminations being affected. And if it's timber in various orientations, be it ultimately down to a cross-laminated product or a glue-lam product, then it's what laminations have been affected and where is it in the strength pattern of that beam. If it's all at one end, that's a different repair to if it's in the middle or if it's at a third point. And you've just got to consider the whole structural aspect. If it's an engineered product within the mass timber environment, then those need different approaches to consideration of repairs. If it's a flange, you've got a chance. If it's the web, that gets very difficult very quickly. So the options, the what if. What does the customer expect from those repairs? Are they expecting this building to be put back as originally designed, or as originally they wanted the performance? They can be two different things. It's amazing when you start talking to customers at the end of the job, well, I never wanted that, I wanted this. And while you're at it, can we have an opening there? And so on. So the repairs need a debate with the end customer. And maybe it's replacement. Is it a repair or is it replacement? In some instances, I want it demolished. I want this building out of my hair. I don't want it anymore. It's given me so much grief, just get rid of it. Now that's not a decision we can make as engineers to look at repairs, but it's a cost-benefit analysis to be done. And the material options with what you do. And you have to address the fact, what if it happens again? So you're going to do all you can to get hold of the designer and the contractor and all the parties involved and find out what is the following trades. What are they going to put on top of this? What are they going to put underneath it? Is it suddenly going to become a steam room? And have we got to redesign it in accordance with that? Where's the membrane? Where's the vapor control? Where's all these parts? Now, what if the original design was flawed? What if that warm roof construction, the VCL was in the wrong location? What if in that warm roof construction where that mass of timber, which is a good insulator in itself, is stopping the condensation going all the way up through? What if it's condensating on the underside of the dreaded single-ply membrane? Where is the condensation profile? What about at the support conditions? What about at those profiles? Has a full condensation risk analysis been carried out to see where the condensation points are at certain times of the year? That's what needs to be put down so that folks can understand where they're going with this. So materials for repairs. We've all got our own list of materials, we've all got our own toolboxes of what we like to use. It could be new timber materials coming in to the box, if you like. I'm quite keen myself on resin repairs. Worked for it for many a years, and I find once it's properly designed for the end application, it works very well. But it could be putting in some dowels, steel dowels, connecting things together. It could be carbon fibre. We've done carbon fibre connections and the like. It could be steel plates to try and maintain the structural continuity of the item you're looking for. Here, that's actually resin repairing some I-joists. So, the action, the repair. Let's look at one of the types of examples that Phil was showing. You've got decay being identified with some form of water issue at the base of the wall. So you expose the base of the wall. You may want to prop it. you may not want to prop it. And we'll talk about that in a moment. Once you're happy that you can cut away the decayed section. So let's have a look at that. This is a technique that we often use, and I know others do as well, is that you map out the profile of the decay. You know where the decay line is. You then treat it like underpinning. You do a small section, cut it out. There's one being cut out there. And you notice there's a core here. You're looking all the time to see, have you caught all the decay or have you got ongoing moisture? Doing a core, pulling out a core of that will show you where the moisture highway is. And that's a very good technique to see where the difference is coming from. You then treat the area that you need to prepare it and install your filler block. Now that could be timber going back in, a glue lamp, could be CLT, or it could be steelwork, depending on the final design and the criteria. If the original design is not flawed, then there's no reason why you can't put back CLT in that condition. And then you carry on along the length of the wall. And most times we do that without any temporary propping. Or we might need to support one floor, and we do it from one side. So you don't need to excavate both sides, or locally. And that's on the back face of one that's been repaired. So we didn't need to go in from this side, we went from the other side, and that's been repaired all the way along. Different heights because you've got different moisture profiles, decay profiles. And without propping, that particular one. If the design was flawed in the first place, then you're more likely to want to replace the CLT, the timber in that location, and in this instance, small lengths of steel used for that application. And sometimes you would need to increase the holding down, you need to put some large straps, and you extend the straps upwards, and you can replace them with higher levels. You might want to use carbon rods in slots if you've got a particular tall repair, because you're looking at the buckling and bending of that wall in that instance, so that you can maintain the original structural integrity of that wall in the first place, based on the design or whatever was being asked for. And necessary to connect the various parts together to maintain the shear resistance and the sliding resistance of the structure. Floors, roofs, similar pattern. Identify first of all the profile of the decay. Has it gone down a joint? Has it gone down a particular avenue? What is it? Most times in floors, if it's deep decay, it's gone through several lamellas. Often it will miss a lamella and it's on the next one below because of the way the grain orientation or the way the moisture's got into it. So you do need a full profile through the beam to identify where is your decay. And we'd simply, quite often we've cut them out. Just cut out the whole length of the decay, and then it's a straightforward process of reinstating either glue lam back into that space or a CLT member back into that space, depending on the width of that slot. You might want to bind them both together to ensure that they work compositely, so you're looking at some diagonal screw fixings of that nature, or you might want more of a clever half joint, but by and large we find that works perfectly well. I don't know if you can see there, that's a whole floor being replaced for the whole length there. And then tied in to maintain, because that was a continuous slab, you've got to maintain the structural bond between the two layers, the existing good CLT and the new. So that's fully achievable in that way. Now we heard earlier that sometimes the decay is only local to the top surface or the top lamella, in which case it would be silly to cut it all out, all the good construction. It might be that the slab itself is well okay. It might be designed for fire, in which case it's got more lamellas than it needs to have. It may be that you can simply remove the decayed area and fill it with plywood or another material that's such, if it's got no real structural performance needed. However, if it's something that needs to be structural, then you're likely to want to take out a longer length. You will need longer lengths taken out beyond the local repair so you can bite in to good material or ensure that you've got a full bond on a repair. So you would dig it out and you simply put back in a plank. The CLT would have been designed or built using graded lamellas, planks, and you can replace that, providing you get the right shear, the right bond across the interface and the connectivity of the adjoining planks. So you will need some finger jointing using carbon fibre plates or other processes, and that's when it starts structural and you've got various connections to consider. So there are lots of techniques, lots of ways of looking at this, and no one size fits all. Every job needs to be assessed, what it is they want, what does the customer want, as we went through earlier on those aspects. CLT columns, it is a thing. We found sometimes, particularly at high level, if they're projecting columns to the outside world, would have been protected by some form of cladding that hasn't been detailed correctly, so water's getting in behind it and being absorbed by some of the end grain lamellas. Then you've got decay in them. These can be very difficult for temporary works, so we look at putting additional timbers at a temporary measure to stiffen that area up, and those are structures secured to the defective member. More often than not, I've always found that decay happens right at mid-height where the worst stresses are for that particular column, and so we end up having to often put reinforcement in that before we do the repairs to get access to them. It's all about logistics. It may be that it's easier to cut it out and put a new column back in. It all depends on the scale of the decay and the conditions therein. Sometimes we've had to do complete new feet on the bottom of columns, CLT columns and connections and so on. And it all depends on the strength and stresses at those locations as to what. These are all new, that's existing there, that was the decay zone, and necessarily to put back the structural integrity of that location. So, the are you serious moment now. I mean, I could say to architects, apologies amongst you, are you serious doing that detail? What are you thinking? I could say to the industry, are we serious? Can we really advise the customer correctly? Are we serious about the skills of the contractors? I know there's quite a number of contractors in the audience, and I realise I'm signing my own death warrant now. But are we serious about the competence? Are you as limited as I am? I think limited companies should be proud and say, no, I can't do that, I'm limited. And what is the durability of the protection levels being specified? I'm going to use that product because it's cost effective. And as long as it lasts 10 years, I'm out of here. Are you serious? Is that, I mean, those are the sort of conversations I think you should have with customers. And identify what it is that could happen. What could possibly go wrong? Every design meeting should be, what could possibly go wrong? That's why I'm not invited to many. Cause and effect. It's the thinking. Think, think, think. We've got it in our heads about CDM now and safety on sites. We're all on sites thinking safety all the time. We walk around now like some space-age person with all the gear on, and all the gloves and all the glasses and all the hats and all the coats and all the fluorescents. Yet we don't think properly about the buildings. In the manufacture. How is it being manufactured? Where is it being stored? Where are they putting the panels after they've made them? Where's the quality control sign-off? Has that been processed all the way through? Has the moisture contents of those products been handed over to the next person, like a relay race? External storage, big problem. Transport. Driving rain. Or trapped snow. Storage on site. Flood. Groundwater. Is it being thrown in the puddle? I know no one does that anymore, apart from most of the sites I see. But is the site got high humidity? What do I mean by high humidity? Is it the winter time? Have we got a winter kit as opposed to a summer kit? We've got to think these things through. What is the storage on site? Where is it going to be? Is it storage on site is the floor level before? And what if there's a delay? Has the program and the logistics gone mad and said, I want to do a complete horizontal run? I'm not going to go vertically. I'm going to go horizontal. Is that a good idea? Sometimes it is. But sometimes it isn't. During assembly, how much exposed grain is there? How many times have I seen glulam columns put in concrete pockets? And a lot of the world, a concrete pocket's called a swimming pool. So if you said, I'm going to put a glulam beam in a swimming pool, would you do that? No, you wouldn't. So there's not a lot of difference in construction between that pocket and a swimming pool. Exposed end grain. Where are the sensitivity of the components? Which needs better care? And some of the new detailing coming through now is fantastic with proper steel plinths, steel post supports and so on. Now during the assembly process, yes, it will rain. Yes, some of your tapes will come off. Yes, some of the water will get in. So it just needs to be addressed, QA'd, and it can be done properly. And it can be done appropriately. But if you entrap that moisture, yes, it might dry out, and you might never hear about it again. But if I've got my science right about timber, it's got a great memory. Engineers know it is creep and deformation over time. But I think timber technologists know it as a reduced threshold for decay. Also, you get a situation where if you've got a bit of moisture in there and you've got some condensation coming up, it adds to it. And it generates itself, gets its own little microclimate going. And so, entrapped moisture is a problem. We need to think about how the QA procedure of the handover process. Check the pockets, check the joints, check the interfaces where the steel comes to the timber. In service, yes, leaks from rain and weather, an obvious one. Floods, maybe not so obvious. Maybe ground level's changed. Maybe the Landscape works changed. Maybe the landscape works now, they're 300 mil above internal floor level when they used to be, in the design process, 150 below. Is there some change in the way that the building's used? In-service checks, think about where that moisture could come from. And this should all be discussed at the design team meetings in the very early stages, so everyone's got full knowledge, eyes wide open, of what's going to happen. So maybe, I started off thinking, have we got a problem? And if anyone actually looks up this phrase, they will find out it's actually misquoted. And that's why I think the CLT industry, the mass timber industry is at the moment. We've been misquoted. Yes, we did have a problem, but the real quote is, Houston, we had a problem. And we can solve this now, and it can build it back up. And we are learning, and we have learnt. And I'm seeing better designs come through, and better consideration. But we've got to keep going forward, got to keep asking, particularly with the follow-on trades and the different products and the balance of that. So I hope we're going to be, there's this little smiley person in there, and I think that's what we're going to be. So thank you for listening.